Okay, I'm going to run through one more example of linear programming. So in this case, a truck can carry at most 4,000 pounds and 2,000 cubic feet of cargo. A TV weighs 40 pounds and occupies 3 cubic feet, and a Blu-ray player weighs 25 pounds and occupies 2 cubic feet. If the trucker gets $5 for each TV and $4 for each Blu-ray player carried, he wants to load the trucks to maximize his revenue. Okay, so constraints here are the pounds and the cubic feet. So this truck can carry at most 4,000 pounds, and let's see, so that's the total. So he can only carry 4,000 pounds at most. So these are going to be less than or equal to's. And at most, they can take up 2,000 cubic feet. Let's see, a TV, so going across the TV, it weighs 40 pounds. We're letting TVs be X's, and occupies 3 cubic feet, so we're going to let that go there. And a Blu-ray player, so those are going to be our Y's, weighs 25 pounds, so 25 per Y, and occupies 2 cubic feet, so 2 per Y. So there we've got then some pounds and what they can add up to, and the cubic feet and what they can add up to, and the trucker gets, let's see, $5 for each TV, so 5 per X, and $4 per Blu-ray player, so per Y. And again, we don't know this. We want to figure out what is the maximum. So there's all types of numbers, values that can go there, but we are specifically interested in the max. So let's see. Our constraints are 40 pounds per TV plus 25 pounds per Blu-ray player cannot exceed 4,000 pounds. And the other one is that 3 cubic feet per TV plus 2 cubic feet for Blu-ray player cannot exceed 2,000 cubic feet. Okay, let's find our intercepts so that we can graph these lines. If I do my zeros, in this case I will get 0 for X will give me 160 for Y, and 0 for Y will give me 100 for X. And I'm going to color code this one red. If I put a 0 in for X, I'll get 1,000 for Y, and if I put a 0 in for Y, I'm going to get 666 2/3 for the X. The objective function, as a reminder, we are trying to max or min, in this case max, the revenue. So R equals 5X plus 4Y. Okay, coming over to my coordinate plane, I need to graph 0, 160. So it looks like they're counting by 25s. So this would be 25, 50, 75. No, wait, that's not what they're counting as. They're counting with, let's see. They're counting by 50s. So this would be 50, 100, 150, 200. So 160 would be just above here. And 100 would be here. So it's a very small little area. And the other one would be 0, 1,000, so way up here, and 666 1/3. So here's 650 and here's 7, so 666 2/3 would be like right here. These both happen to be less than or equal to's. So if we put in the zeros, which are available, 0 is always going to be less than or equal to that value. So it means we end up shading below each one of these. So we're going to shade below the red line and also below the blue line. So the only place where both shadings occur are under here. This is kind of a interesting one, a weird one, because what ends up happening is that this higher constraint doesn't even really matter. we are totally constrained by the first one, which is the pounds. The cubic feet are almost irrelevant in this situation. Okay, so corner points, we also are lucky on this one. The corner points are all available to us. We don't have to go hunt for one because the corner points of our feasible region are these 3 points. So we have the point 0, 160. We have the point 100, 0, and the point 0, 0. Now, the point 0, 0 is the easy one. If we put in zeros, we get no revenue. If you don't carry any TVs or any Blu-ray players, then you don't make any money. So that one's easy. If we do 5 times 0 plus 4 times 160. So if we carry no TVs and only Blu-ray players, we make $640. And if we carry only TVs and no Blu-ray players, then we make $500. So it's weird a little bit that the only options are to carry either nothing, all of one item, or all of the other item. That's the only options that there even end up being at all in this problem. The max in this case ends up being this top one. So for the final solution here, 0 TVs and 160 Blu-ray players will max the revenue of $640 per truckload. So obviously, if this company or this driver only ever carries Blu-ray players, it's probably not the best solution. At some point, he is going to have to carry some TVs. People need TVs as well. So is he going to be able to achieve this maximum for every load? No, probably not. But that is what would be the best case scenario for him.